Welcome to this lectures on problem solving and programming in C. This is seventh lecture of the course. The title of the lecture is Introduction to C Programming Language. We will see in this lecture, we will see history of little bit of history of C programming language and what are the what is the organization of C program. what are the main ingredients of the C program? How to form expressions, how to input, how to take output, and we'll also see sample C programs. What are the data types? What are different data types, basic data types available in C language? Right. So all those. This is in the last class we have seen how to translate an algorithm to C programming language. So in this lecture we will primarily focus on introduction to C programming. So the C programming language was created by Dennis Ritchie in 1970 at Bell Labs. It is basically C programming language is successor of B programming language. And the C programming language, it has long-lasting use in developing operating system kernels, device drivers, network protocol stack, etc. The C programming language, because of its faster in execution times, it's a preferable choice for developing operating systems and network protocols. Um, and its use in application software has been decreasing because there are a lot of new technologies coming up, and they replaced the mm, earlier someone who used the C programming language, and since there is a more advanced technologies are available, people are slowly using those technologies instead of C. But still, C language is more relevant when it comes to operating systems and networks and low level programming. Okay. So the C, basically C programming language is an imperative procedure language, and it supports structured programming concepts. So it is programs are built using structured programming concepts, like sequence selection and repetition. So let us see a sample C program and see what each statement means. Okay. So this is a C program to compute maximum of three numbers. We have seen an algorithm in the last class on compute maximum of three numbers. So every C program will have a function called the C program execution starts at a function called main. This is the main. Main begin brackets and end brackets. This is called function main function. Okay. And so what this int determines is the function, this function returns an integer value to the user, to the caller. The caller may be operating system, or the function, the program can may be called in some other program also. In that case, the return value usually indicates that whether the program is successfully completed or unsuccessfully completed. Depending on the situation, we will return a value. Nothing is returned from this algorithm. By default, zero is returned. Usually zero indicates that successful completion of the program. Okay. The int main, and this is the function where the C programming language execution starts. Okay. And then we have seen how to translate an input statement. So here we have combined three integer instead of int a, int b, int c. We can declare them like this, three variables, and even I can read three numbers ABC with a single statement like this. So basically, we have data types to declare variables. Variable are very, as I told you, variables are basically data holders. They have a place in the memory and they contain different kinds of data. So since we are talking about data, there are many kinds of data in the real world. So which data you are trying to store in that variable, that will be determined by the data type. So here integer means this A, B, C are takes the values of integer data type, integer values. Suppose if I want ABC to maximum of real numbers, I may have to declare using float or double data types. Float or double data types, which represents decimal numbers, decimal fraction, real numbers basically. So, and this is the if construction, one if construct, and then this is another if constructed selection statement inside another selection statement, and this is else part, if else statement, and there is another if inside the statement. Okay. So as I discussed in the previous class, while you're translating an algorithm to C program, first thing you need to write is empty C program, which includes only int main, the and big curly braces and begin and end curly braces. Since we are using the printf statement, printf and scanf statement, we need to include their definite declarations. What is the prototype of this function? Those declarations are available in the header file called stdio.h. Okay, basically this indicates that it will give the information about printf and scanf statement, what kind of data they accept, and what is their data types. So all those things details are mentioned in the header file. They are called prototypes. These prototypes of the printf scanf statements are available in stdio.h. Otherwise, if you forget to include this stdio.h header file, you may get warnings. So to avoid that, we need to include whenever we are using printf scanf statements, we need to have a practice to include the stdio.h header file. This is a simple C program to compute maximum of three numbers. Right. So whenever you are learning any program, any programming language, first thing is you need to understand how to write an empty program. For the first step, you need to learn. And then second step is how to read input from the user or how to write input to the user or the display device. Those input statement we need to learn. So in C, we have a scanf function to read information from the user. We can read a variety of data from the user. It may be integer data, real numbers, or character strings. Variety of data can be read using this scanf function. Similarly, printf function is used to display the output to the user or display device. Okay, so the printf statement can also print variety of data, integer data, character data, decimal real numbers, or character strings. A lot of variety of data it can be used to print to the user. So next thing is how do you when you're talking about we are talking about variables in real world we have integer numbers, real numbers, character strings. So what are the corresponding key data types to create variables of such of these kinds of data? Suppose if you have integer variable, we have a data type called int. The keyword is int, and the format specifier. Format specifier is basically we use the format specifier in scanf statement whenever, for example, here since I am reading three integers A, B, and C, I will give %d, %d, %d. %d stands for we are trying to read an integer from the user. Okay. So for integer data type, the format specifier is %d. For real numbers float, we have two kinds of data types for real numbers. Float, which is %f is the format specifier, and double, which is %lf for the format specifier. Like in IEEE 754 representation, where we use single precision and double precision, you can assume that this is single precision, float is single precision, double is a double precision, where the range of values we use 64 bits to represent the real number, whereas float usually we use 32 bits to represent the decimal number. I mean real number. Character, if you want to read a character from the user, we have %c. Similarly, we have if you want to read a string is basically a sequence of characters. We use %s that anyway comes in later part of the course when you are talking about lists and arrays. Okay. Apart from these basic data types, we can add type um, uh, uh, modifiers to bring in more data types. For example, if I say long int, short long int usually 32 bits, 32 bits size, whereas long int usually takes 8 bits size. Okay, so these are basically by using unsigned. If I say unsigned int, and int, it means that we are depending a data type which holds only positive numbers only. There are no negative numbers. So all the negative numbers will also be see. So we'll have suppose if you have right now what is the range of numbers you can represent using integers. So if you ignore all the negative numbers, the number of numbers, positive numbers that can be represented will be more. Okay, like that we can even say short int. 14th, or else you can say long double. Okay, these are more precision. So like this, these are modifiers to basic data types. By using these modifier data types, you can have a flexibility to better range or shorter range for the data types. So while writing computer programs, you may have to use a lot of arithmetic expressions. So that is why we have arithmetic operators. Arithmetic operators. So what are the arithmetic operators can be treated as two kinds: binary operator and unary operator. Binary operator is plus. One of the some of the binary operators are plus, minus, multiplication, modulus, and division. So this is how you can write. Suppose if I write n equal to n by 10, it means that we compute n by 10 n division by 10, and then that is assigned to n. Okay. These are binary operators because it needs two operands. Suppose if you want to perform addition, you need at least two numbers, right? Two numbers to add. So that is why they are called binary operators. So modular operators, for modulus operator, we use percentage symbol. For multiplication, we use star. And for division, the division symbol will be used. Yeah, the C language also provides unary operators. Unary operators, some of the unary operators are unary plus, minus, unary plus, and unary minus. Unary minus is basically, suppose if you want to say x equal to minus a plus b. So here minus a is the unary operator. Minus is the unary operator. Unary operator means it has only one operand only. Okay. And the increment and decrement operators are also unary operators. So suppose if what do you mean by increment operator? Suppose if x plus plus means x equal to x plus 1. This is a short operator. So similarly, x minus minus means x equal to x minus 1. Okay. There is a slight difference in this is called post increment, this is called pre increment. Similarly, this is called post decrement, and this is called post pre decrement. So there is a difference between post increment and pre increment, a slight difference that we will learn in some part of the course. Maybe in some coming few lectures, we will know what is the difference between pre increment and post increment. But at the moment, that is not very relevant for us to know. So whenever you want to do a x equal to x plus 1, you can safely use x plus plus, because this is a unary operator and it's a short expression, right? Yes. Here, if you see here, this is equal to is assignment operator. So when you're saying a plus b, the sum of a plus b will be computed and saved it in the variable c. This is called assignment operator. Is equal to is the assignment operator. And whenever you are writing programs, especially in selection statements, we always compare numbers, whether they are equal, less than, greater than, equal to, like that. So for that, we have relational operators. What are the relational operators? We have is equal to. Since equal to is equal to, since for example, is equal to is assignment operator, right? Assignment. So to distinguish between assignment and equals to comparison, equal to is used, double is equal to. So double is equal to is equals to operator, and there should not be any space in these operators. Double is equal to, they should be typed next to each other. Double equal to. So we can say something like if a equal to b, it means that the condition will be true if a and b have the same value. Not equal to. Not equal to is like this. Not equal. This is the not equal to symbol. This condition is will be true if a and b have different values. Less than is the symbol, very we know that. Less than or equal to is the symbol. Less than or equal to. In mathematics, we have something like this, but we cannot have the same symbol in C. So that's why we have less than followed by equal to, and greater than equal to. So these relational operators are very much used in selection statements when you are comparing whether a particular value are same, or which one is smaller, which one is bigger. Those kind of comparisons we can do using relational operators. And logical operators. Suppose if I want to compare more than one expression, if my condition, I want to prepare a selection statement where I have more than one condition. Suppose n greater than 0, greater than equal to 0, n less than 10. It means that n should be between 0 and 9. So it's a single digit number. So if I want to compare like this, so this is logical AND. Logical AND means both this has to be true and this has to be true. Then only the final entire expression will be true. And we have logical where either this has to be true or this has to be true. So if A greater than B or A greater than C, it means that if any of them is true, then the entire expression will be true, otherwise false. So logical not is basically if n less than equal to false, then not of n less than equal to 0 will be true. The opposite of the expression will be true. Right? These are the logical operators where you want to combine one or more arithmetic, relational operators to in a selection statement. So they are very much handy to write shorter and compact programs. So how do you form arithmetic expressions? We combine one or more operators to form arithmetic expressions like we do in mathematic expressions. In mathematics, we have a lot of expressions, right? Like that. Same way, how do you evaluate a mathematical expression? So we have Bodmer's rule in mathematics, which says that brackets of um, division, multiplication, addition, subtraction, right? This is the order in which the expression will be evaluated. Like that, we also have a operator's precedent that is very similar to Bodmer's rule. And suppose, for example, if you have a 10 plus 20 multiplied by 30 minus 40, will evaluate to 570 because first 20 multiplication has high priority. 20 and 30 will be 600. 600 plus 10 is 610. 610 minus 40 is 570. Suppose if you want to override the default operator precedence, we may have to use brackets. So suppose if I have expression like this with brackets, so this will be evaluated 10 plus 20 is 30 and 30 minus 40 is minus 10. So 30 into minus 10 is minus 300. So using brackets, we can create our own operator precedence and override the default operator precedence. So like in many cases, many programs, we use arithmetic expressions very frequently. And if we have a specific arithmetic expression, we need to see whether to use brackets or not. And it's always a good practice to use brackets because there will not be any confusion in the that will avoid logical error. Let us see small example how to use uh, logical operator, arithmetic expressions and data types. This is a program which converts degree Celsius to Fahrenheit. Degree Celsius to Fahrenheit. So suppose if we give some number in degree Celsius and it will return the Fahrenheit value of the particular degree Celsius. So we have since Fahrenheit and degree Celsius are real numbers, we are using a double precision real numbers using double Fahrenheit, double Celsius. And then using this printf statement, we are reading the temperature in degree Celsius and see this %LF is a format specifier for double data type. So we read a real number with double precision and that is stored in the degree Celsius variable. And the Fahrenheit is converted using Fahrenheit is equal to 9 multiplied by Celsius division 5 plus 32. This is the standard formula to convert degree Celsius to Fahrenheit. After that, I display the temperature value in Fahrenheit. I just need to display the value of the variable Fahrenheit. And since it is a double data type, we use %LF. And this is the new line symbol. Suppose if you want to, after this program, you want to start everything on the next line, so we use a backslash and backslash and is basically new line symbol. And this return 0 is, even if you omit this return 0, by default the program, the main function will return 0 only. So it's a default value for return is return 0. It's a good practice to put the return statement in main. So so thank you for this lecture.